Hello, everyone. Thank you for joining with us today. So today's topic is how to choose one of the specific classification problem based on precision or recall. We will begin shortly. Hello, everyone. Welcome to the webinar from Byte Academy in Nestria. Thanks for joining with us. This is Shubhankar. I am a data science instructor at Byte Academy. Well, before we get started, please join us in our free Discord community to enhance the experience of this workshop. I will be sharing the resource files on Nestria Discord server at the end of this event. The Discord and Nestria link has been shared in the description box. Okay. Before we get started with the topic, let me tell you a little bit about the Nestria. Basically, Nestria is a Byte Academy's sister company, and you can think of it as a portal for everyone from networking to technical and career advice. So you can just explore Nestria, and I will also going to give you the tour of Nestria after the event, at the end of this event. All right. So let's get started with the topic for today. So the topic is precision or recall. Which one we supposed to choose for a specific classification problem? One thing before we go ahead. So today's topic will going to be definitely about the performance matrices. So you need to have a little bit knowledge on the machine learning part. Okay, but I will start with the agenda, and over here you will be able to understand what we will be going to discuss. So first we will discuss about the performance matrices in machine learning classification problems. It will be specifically, the discussion will be about the classification problems, all right, and the performance matrices we use in those classification problems. Next is what is accuracy performance matrix, all right. So what does it mean? How we define that? Next, why accuracy is not a good performance matrix for classification problems. Accuracy is one of the performance metrics, but why we cannot choose accuracy as the performance metrics in each and every case. All right. What are its limitations? We will try to understand over here. Next is what is precision and recall. Okay. So these two, as I said before, also comes under the performance metrics. We will see the definition of precision and recall, and we will try to make sense what this exactly means. Okay, next is how to choose among precision and recall for a specific problem. So whenever we are tackling a specific classification problem, we need to choose between precision and recall, or we need to pay attention or more focus on either precision mode or in recall mode. All right. So we will see how we can decide that for a specific case study. All right. And after that, we will do 2 case studies. So first, performance metrics for machine learning classification problems. Now, we know that, in machine learning, we design different models. All right. And let's say in machine learning, we got a classification problem. And in classification problem, uh, we have designed a machine learning model. Now, definitely we need to check how well the model is performing, right? And for that, we need to take the help of performance matrices. All right. So for classification problem in machine learning, we have many different type of performance matrices. One of them is accuracy, next precision, then recall, then F beta score. All right. There are more. Okay, but here in this in today's session we will mostly focus on accuracy, precision, and recall, right? Yeah, so let's understand what is accuracy performance metrics first. So its definition is very simple and straightforward. Accuracy is the ratio of number of correctly classified data points to the total number of data points. And I will try to give one example over here. Let's say here we have got some sample data. All right. We have received some sample data that tells about basically how many hours a student study and what is their outcome. All right. So 5 hours study, let's say the student has passed. 4 hours study, the student has passed. 2 hours study, the student has failed. All right. So similarly, we have got this data. All right. Now we have designed some machine learning model to predict for the unknown data. Okay, we will feed that machine learning model that, let's say, 3 hours, and it will going to tell the result, or it will going to predict the result. I need to say, right? Predict. It will predict, not tell exactly, right? So over here, let's say my machine learning model is prepared and I have tested it, and I need to check how nicely it is performing. So on the right hand side, this orange color graph over here, or orange color data, it indicates the predictions that was made by my machine learning model. All right, I have fed 5, it said pass. I fed 4, it said pass. I have fed 2, it said fail. So similarly, you can see the results, right? Now over here, let's say for the 3 hour, actual result was pass, but it has predicted as fail. Actual for 4 hours, actual result was fail, and it has predicted as pass. All right, so these two gone wrong. So how we can measure the accuracy? So total, how many correctly classified points? So over here, 1, 2, 3, 4, 5. 5 correctly classified points. So 5 divided by how many correct total number of points. So total number of points means basically how many correctly classified points plus how many wrongly classified. So total 5 plus 2, 7. So 5 by 7, the model accuracy is 72%, we can say, right? So this is straightforward. What does it mean by accuracy? And this is how we can, decide how much, how better my machine learning classification model is working. Now, next, if we look at why, we will just try to understand why classification is not a good performance matrix for classification problems. I mean, like accuracy is not a good performance matrix. So we'll try to understand why. All right. Now, let's say I have, again, shown the data over here on the right hand side, and I have changed the data a little bit. You can see that 5 hours pass, 4 hours pass, and this is the data I have collected, imagine, for some time. Okay. Here, with the situation when we cannot go for accuracy performance metrics, or when the accuracy performance metrics won't be, reliable to decide how well a model is performing. That is, in classification problem, if the data set is highly imbalanced. What does it mean by that? If you look at the result over here, only one failed data I have got, rest of the past data I have got. This is completely imbalanced. This is called as an imbalanced data set, because the ratio of pass and fail data that I have, it is almost very worst it is looking, right? Only out of the 7, only one failed data I have and rest of the things are passed data, right? So that's why this is called a highly imbalanced data set. Okay. Now, when we have this kind of data set, accuracy score will not going to be efficient or will not going to be reliable to tell how well my model is doing. Okay. Now, let's say why. Now, over here, even if the model, let's say I have fed this data to my model and I am not, right now I am checking the accuracy of my model. All right. Now you see, if even blindly, okay, let's say the model is absolutely worst, okay, but even blindly, this model predicts all the data points as pass. Okay, for 5 it is returning pass, 4 pass. For every data, whatever I am feeding it, it is returning pass. Still, according to the actual database, you see only one will be wrong and rest of them will be right. So what will be the accuracy score? Out of 7 data, 6 are right and only one is wrong. So 6 by 7, the accuracy of the model will be 86%. But that is not at all, reliable, right? The data set, because here the model, even if it is doing things blindly, still it is getting 86% accuracy. So when the data set is highly imbalanced, we cannot go with accuracy to, to decide whether my model is has a better model for classification problems or not. All right. So that's why we have different other types of uh, performance matrices. So next is we will try to look at precision and recall. So that is the problem, for the reason why we brought the concept of confusion matrix. All right. So let's try to understand the concept of confusion matrix for now. So this is how it looks, the confusion matrix. Okay. Now, first we need to consider one class as positive. All right, one class as positive means, what does it mean by class over here? This pass and fail is called as a class over here. All right, either it's a pass class or it's a fail class. All right, now any one of the class we need to consider as positive first. So let's say pass I'm considering as positive and fail I'm considering as negative. All right, so next let's look at the data. So over here I have put study hours. This is the actual result, the data that I have, and on the right hand side I have put what my model has predicted. Let's say I have fed this data to my model and this is the actual result, what it's supposed to give, and this is the predicted result, what it is giving. Okay, now let's compare. When the actual result is pass and my model has also predicted pass, we say it is true positive. All right, why true positive? First of all, whether it is positive or negative, we are going to tell in terms of whether the predicted part is telling pass or fail. So pass we have considered as a positive entity, right? So that is the reason we are saying it is a positive answer. Next thing, whether it is true or not, for that we need to compare the actual and predicted result. So if the actual and predicted result is matching, we call it true. Okay, so over here, so it is returning me pass as a predicted result. So it is positive, pass and pass, it is matching. So true, positive. Okay. Next, if it is actual result fail and predicted result fail, obviously it is negative because it is saying fail and indeed it is true, right? It is matching with the actual result. So true, negative. Okay, this is how we define true positive and true negative over here. All right. This is the count that we are going to write. Like among 4, how many? One is true positive, one is true negative. So we will write 1 here, we will write 1. Okay, it's just the count. Okay. Next, we will look at the formula. Right. Now here I'm just trying to explain what does it mean by true positive, what does it mean by true negative. Next, similarly, we have false positive and false negative. What does it mean by that? It means simply, they say if the model is predicting fail, definitely it is a negative, something it is telling, but whether the negative is true or false, obviously that negative, whatever it said, it is false because it is not matching with the actual result. So false negative. And similarly, it has said pass over here, so it is positive, but it's a false positive because it is actually not matching with the actual result. The predicted result is false. It's not true, right? So false positive. All right. Now over here, we need to compare the actual result and predicted result for our model. All right. And then we need to write the count in the formula. So let's see what is the formula for precision. So formula for precision is true positive divided by true positive plus false positive. All right. So number of true positive, you write over here divided by true positive plus false positive. And it will give you the precision score. Fine. Similarly, in the recall score, what we do? True positive, the number of true positive divided by true positive plus false negative. All right. So this is how we calculate the precision and recall. And this is how we derive the, this true positive, false positive, or in one term, we derive the precision and recall from this confusion matrix. All right. And why we made this confusion matrix? Because in classification problem, accuracy is not really a good performance matrix. And that's why we implemented this new concept of, or we have brought the new concept of performance matrices inside performance matrix. We have brought this confusion matrix concept. All right. Now, next, so we have already seen how we what is exactly precision, what is exactly recall. Now the question is which one to choose to test my model, whether my model is good or whether my model is bad. Which score I will look at which score need to be more in order to be for my model to be very good. All right. So let's say in words what precision actually means. Basically, precision means the ratio of correctly predicted as positive by the model. All right. And how many times in total model has predicted as positive. So it is basically the ratio of these two. Okay. Correctly predicted as positive means how many times my model has told something positive divided by how many in the model has predicted positive. Okay. So first is correctly predicted positive, and second is how many in total it has said positive. All right. It is simply, we can take this as how many my model has correctly predicted positive divided by how many my model has said positive. Let's say my model has said positive 10, but it was correctly said maybe only 5 times, right? So this ratio is called precision. Next is recall. Ratio of correctly predicted as positive divided by how many number of positives are there in reality. Okay. Now, in reality, maybe there are 20 positive results, but how many of them, was correctly predicted by my model? Maybe only 10, right? Or only 5, right? So that ratio will going to give me recall. Okay. The formula that we have seen in the last slide, these two definition or these two explanation basically tells in words what does it mean by precision and what does it mean by recall. Okay. So precision, if we closely look at this definition, precision can be seen as the measure of quantity, right? So why? Because in total, let's say my model has said 10 positive, but only 7 of them were correct. Okay. So that's why precision is basically the measure of quantity. And recall, we can look at it as, measure of quantity. Means how many in reality actually positives are there and how many my model has correctly said as positive, okay, among the all. So that's why we can also think of recall as a measure of quantity. So now if you want to reduce, now these two facts we need to keep in mind. If we want to reduce the number of false positive, we need to focus more on precision. And if we want to reduce the number of false negatives, we need to focus more on recall. Okay. Now, what does it mean by this? Now, let's say my model is predicting the results, and in the predictions, there are more number of false positive. What does it mean by false positive? Let's say my model has said something positive. Positive means they say pass, yes, all right, these are positive, right? So let's say my model has said pass and it was wrong. When my model said yes, this many hours, the person has passed, but it was wrong. In reality, the person actually has failed. If you want to reduce that number, okay, in that case, you need to focus more on precision. Similarly, false negative, if we see, false negative means my model has said the person has failed, okay, but in reality, the person actually was, got passed. So here also my model has made a mistake, right? So it is not predicting the reality properly. So in that case, if you want to reduce that particular error from your model, you need to go for recall. All right, but there is a bottom line over here. All right, so this is, the decision is purely, so which one you want to reduce, or which one where you want to focus more, whether you want to reduce the false positives or whether you want to reduce the false negatives. That decision will be purely depend upon the domain you're working in. All right, let's say we will be seeing two examples, okay, in two different domains, and we will try to understand this, but it will be purely depend upon the domain you're working in, and definitely it requires the intervention of the domain expert. Okay, so yes, we can definitely with easy formula we can calculate precision and recall, but in where we need to, which error we need to reduce, that will be purely dependent upon the domain we are working. Okay, so let's understand what does it mean by, the domain and how it can affect. So this is the main focus part of this today's session. All right, so here we are trying to understand when to choose recall, when to choose precision, right? Let's see one case study. Let's say I am making a model which can tell that whether email is a spam email or it's not a spam email. All right. Now let's say what is that we will compare, let's say the reality and something that my model has predicted. Okay. And I'm going to put some remark on that. Let's say I understand this subject. Okay. So this is what it means by the domain. All right. So let's say I understand this thing, what can go wrong, okay, in this particular domain if my model is doing or performing bad. All right. So let's say that in reality, the email that I've got is a spam, and my model has also predicted spam. Obviously, it's very good. Next, the email is spam, and my model has predicted it as not spam. Now, over here, the remarks is very crucial. You see, if the email in reality is a spam and the model has predicted as it's not a spam, you are going to receive the email in your mailbox and it will going to be a spam email, which is actually bad, but it is okay. You can still click on the email. You can see, okay, it is something, spam email, you can delete that. All right. So let's see the third, case. Let's say the model, the reality, the email is not a spam, and my model has also said it is not a spam. So obviously it's very good. My model is performing well, but the blunder happens when the email in reality is not a spam. Let's say imagine the email is from your manager. All right, it's a very important email that you need to look and reply within maybe 10 minutes, 20 minutes. And my model has decided that it's a spam and it has put that into the spam folder. So you will never going to know that you have received an email. It has never reached to your inbox. Okay. If there is no communication between, let's say, you and your manager, right? It is a blunder, right? In that case, we can say even this was okay. Spam, even the email was spam and my models predicted not spam, still it is okay. But this situation, we cannot afford it. It is not spam and my model is segregating this as spam and putting inside the spam folder. Okay. So what is this? See, spam is, it is, my model. Let's say we are thinking this as a positive, all right, spam, but it's a false positive, right? because it is not matching. So in that case, you would like to reduce the false positive, right? So if you want to reduce the false positive, you will focus more on precision, right? So this is how the bottom line goes. And this is how, based on the case, we need to decide whether we want to choose, whether we want to focus more on precision or more on recall. It's not that we will completely ignore recall in this case. It's not like that. Okay. Whether my focus will be reducing this false positive or false negative. All right. So false positive, I need to reduce over here. This particular last case, I need to reduce. Next case is, let's say the patient has cancer or not. So there is some machine learning model. It predicts whether the patient has cancer or not. All right. The reality predicted remarks. Let's say the patient has cancer and it has predicted yes. Well, it's performing good. Now the patient has cancer, but my model has predicted as no. It's a blunder in this case, because if the person, it definitely depends upon the system, but let's say after that there is no checkup. Okay, so in that case the person will ignore that, okay, I don't have cancer, but internally the cancer will start to affect that person, right? So that's why it's a blunder in this case. My model should not be doing this kind of mistake more. It should be minimum this kind of mistake. Okay, rest of the thing is okay, right? If person doesn't have cancer, no, and predicted cancer, no, it's very good. But even if the person doesn't have cancer and my model has said yes, let's say the person will be going for next checkup, right? And in that next checkup, definitely doctors will be there. Okay, so there will be technology intervention, right? And it will be proven that okay, the person actually doesn't have any cancer and the machine learning model was wrong. But think about this case. It is an absolute blunder. It is saying no. So if the person ignores that thing, so it will be fatal for them, right? So that's why it's a blunder. So in this case, it's a false negative because it said no, which is false, which is not the reality, right? So in this case, we need to reduce the false negative part. So this is how, and obviously when you want to reduce the false negative part, you need to go for recall. I mean, you need to focus more on recall and you need to think how you can reduce the error, okay? Error of false negative in your model, right? So this is how, we go ahead and decide whether we need to reduce false positive or false negative based on the cases, okay? And definitely in both the case, we need to have a domain expert. We will going to focus on which one based on the, focus on the decisions, how the model needs to be, improved. And one more thing, there are other performance matrices as well, right? The F beta score combines the precision and recall together, all right? And it gives a different type of results. Okay, it is another uh, performance matrix. Okay, we will decide, we will discuss that, but that part of the performance matrix someday later, all right? So yeah, so that's it. You can, how you can choose between precision and recall. And I hope this was helpful. And these are some reference links. It will be there in this particular file. And as I said, I'm going to, sharing this resource file on Nestria Discord server at the end of this segment, all right? So yeah, thank you guys. So yeah, here, I will give you the tour of Discord quickly. This is my Discord ID. If you're joining Discord or if you have joined Discord, you can search with my ID, all right, and you will get me. And where you can get me, there are different channels on Discord. Mostly you will get me in data science and resources and launch. Apart from that, you can also, get me in Python and JavaScript. And today's file, you are gonna get inside the data science resources because it's falls under the data science domain, right? So let me quickly give you a tour of Nestria Discord server. I hope my screen is visible. This is how the Nestria Discord server icon looks. All right. So when you will be clicking on the link that has been shared in the description box, you will be landing over in this Discord server. All right. Now, first of all, you can come to this Nestria, join a topic. Okay. And over here, you need to select whichever topic you want to choose. You can just select Python, JavaScript, blockchain, data science. This is Byte Academy. Okay, and this is India. Okay, if you are joining this icons, or if you're clicking on these icons, there will be many channels which will be unlocked for you, and you can go and visit. In the Python launch, we discuss about different topics. In Python resources, we share different resource about Python. Similarly, same goes for the data science, same goes for the JavaScript, same goes for the blockchain. All right. And there are careers related channels as well, which you can visit. And there's some random fun channels as well that is for entertainment. So overall, this will be very much helpful for you guys. So do join us, okay? And subscribe the YouTube channel for more upcoming videos. Thank you guys. Have a great day.